All right, here we go. One of my favorite things to talk about. You guys know this stuff, the coordinate plane, okay? But the first person to really use the coordinate plane was a guy named Rene Descartes. E-S? Is there an S between? Okay, that's him right there, okay? And you may have studied about him in history. He's famous for a line, for a quote. The quote is, I think, bless you, therefore, I am. Okay, now let me tell you a little bit about, what he meant by that, okay? Rene Descartes was French. He was a philosopher and a mathematician. He came up and developed the coordinate plane that we'll start talking about today. But he was, like I said, he was a philosopher. And one of the things that he said was he wanted to start thinking at the very beginning. Not of time, but really at the very question everything. And what he would say is, you know what? I don't know if other people exist. I may be dreaming it. It's a very real dream to me. It seems very real, but they may not exist. Okay? They're a dream. They could possibly be a dream. Okay? Well, wait a minute. I can touch this desk, right? It must be real. Well, wait a minute. Maybe the desk is a dream. Maybe my body is just a dream. Okay? That it doesn't really exist. All of this stuff is just stuff that my mind is making up. So he kept questioning everything and whether or not it really existed. And then he said, well, what really does exist? And he said, well, you know what? I know this. I'm thinking about all of this, so I must exist. I must exist. I don't know if anyone else does, but I know that I think, therefore I am. I must exist because I'm thinking. Does that make sense what I'm saying? Now, eventually, I mean, as you start reading Descartes' philosophy, of course he believed in the tangible world and he believed that Barrett exists, even when I don't want to. Right? Barrett, you know I'm only kidding. Not really. I am only. All right. But that's where he started. He started by questioning everything. But he couldn't question whether or not he was thinking about all this stuff. That was clearly true because he was. So he must exist, and then he went from there. So the famous quote that he has is, I think, therefore I am. Does that make sense? Did y'all hear about that in history? Is that where you heard it from? Who did you hear Rene Descartes from? From me? Yeah. Oh, and from the poster? Yeah. You see, that's why the poster is divided up into 4 quadrants. Yeah. You see? Mm-hmm. Okay. You know why? The reason is because exactly. The first quadrant where his face is up in this part, right here, and that's both positive, so you get everything. Okay? But in this one, the second quadrant, the x is negative. In the third quadrant, the x and the y are negative. Okay? I don't know. I didn't make it up. But that's why the face is positive, I think. All right? Now, let's go up here and... Oh, yeah, there you go, Ben. Okay, let's talk about these things for a moment. A coordinate plane. A coordinate plane is a graph or a grid with the x and y axis. Okay, this is the coordinate plane. All right? Now, I'm going to scoot down a little bit here. Now, the x-axis is the one that runs side to side, horizontally. That's the x-axis. Okay? The y-axis is the one that runs straight up and down, vertically. Okay? That's the y-axis. All right? Now, so we talked about x and y-axis. You know, if you have one axis, it's called an axis. If you have two, they're called axes. Axes. Okay, that's the plural for axis is axes. Okay, so we talked about that. Now we need to talk about the origin. The origin is where everything originates. Okay? It's where the two number lines, the horizontal number line and the vertical number line, hit each other. The x is at 0 and the y is at 0. Does that make sense, Hannah? And that's why it's called the origin, because that's where everything starts, right there at the origin. Okay? That's the origin. Its coordinates are 0, 0. Okay? All right. Now let's talk about quadrants. Quadrants, we get the quadrants when the number lines divide up the plane. Okay? This is called a coordinate plane, and the coordinate plane with these two axes are divided into 4 parts, quadrants. This is the first quadrant. Here, this is getting a little too crowded, so let me get rid of that stuff. Okay? This is the first quadrant. That's a Roman numeral, and we always use Roman numerals to represent the quadrants. That's the first quadrant. We go counterclockwise. This is the second quadrant. This is the third quadrant. And the bottom right is the fourth quadrant. IV. Okay? What's the Roman numeral for 5, Elizabeth? V. Okay? So 4 is 1 before 5, right? That's why we have one line before the V, meaning 4. Okay? Everybody good with the quadrants? You got to memorize them, you got to know them. Okay? All right. Good. Now I'm getting rid of that. Let's see what else we want to talk about. Talk about quadrants. An ordered pair. An ordered pair. Now let me say something here. Remember, we've got two number lines, right? We've got a horizontal and a vertical. So when I start talking about a point, it needs two numbers to represent that point. It needs a number that it sits on the x-axis, and it needs a number that relates it to the y-axis. Okay? Well, looking at P, what is its x, Daniel? 2, right? Because 1, 2. We have to, from the origin, we have to go out 2 from it. Positive 2, right? What's its y, Daniel? 4. This is an ordered pair because it is always written in the same order. Always. And that order is alphabetical. X, then Y. It's always alphabetical. X, then Y. Does that make sense? We're okay? That is an ordered pair because it's always ordered in a certain way. All right? Let's get rid of that. Now, let's see what else. The x coordinate. Well, we just talked about it right now. Right, just then. When we talked about P, right, its x coordinate is how far do I move along the x to get to P, Daniel? You said 2. So 2 is the x coordinate, and I'll abbreviate just like that. Now from there, how far do I have to move along the y? Up 4, right? And that is the y coordinate. Everybody happy with all that good stuff? That's all very familiar to us. We know it. But I just wanted to bring it back to us. Let us think about it, okay? Now, I'm going to get rid of that. Let's scroll down here and look at example number 1. It says, give the coordinates of the point. And I've given you 2 points. Now it says give the coordinates. You can tell me, what are the coordinates of y, Moreau? Exactly. I move 1 along the x, and then I move 1 along the y to get to the y. And I move down 1, right? Down means negative. Right? That's the number line going up and down. Here's a number line going to side to side. Where's the negative on a number line that goes side to side? Is it on the left or is it on the right? Emma? Think about a number line that we've been using since we were 4 years old. The negatives are on the left, the positives are on the right. The number line going up and down, the negatives are on the bottom, the positives are on the top. Okay? Now, let's do this other point, point R. I'll do that in red. Okay? What are the coordinates for point R, Allie? -3, -1. I go back 3, right? And then I go down 1. to get to R. Beautiful. Everybody feel good there? All right. Happy. Happy, happy, happy land. All right? Oh, man. Now they've given us the coordinates. They want us to put a point on the graph. It says plot the point in a coordinate plane. Describe the location of the point. Now listen, whenever I'm plotting points, I begin at the origin. Right? That's where things originate. Right, Isabella? Okay. Isabella, here I am. I'm at the origin. How do I get to this point?
You go left.
I go left how far? 5? Now how far did I move just then? 2. Each one of those counts for 2, doesn't it? And you want me to go back 5? Okay, so let me do this. 1, 2, 3, 4, 5. You agree? Okay. Now what do I do?
Now go down 3.
Go down 3 because it says -3. So down 1, 2. Okay, I didn't do that well. Let me try that again. 1, 2, 3. And I'm going to put a point right there. Okay? Now, Daniel, what do I put next to that point?
There.
Okay. Let's make it point D. Okay? Everybody happy with that?
Yes.
We know how to get there? Rowan? You good? Okay. All right. Let's look at the next one. Use a coordinate plane. All right, let's use this one. Plot the points 0, 0, 0, 4, 5, 4, 8, 2, and 5, 0. Connect the points in order. Connect the last point to the first point. Identify the figure. Okay, Hannah, help me plot the first one. Where is it?
It's at 0, 0.
And what do we call that point? It has a name.
The origin.
The origin. Okay, good. Where's the next one, Bailey? I'm sorry? We're done with this one. Now we're doing the next point. That's okay.
0 and then
Up 4. There you go. Nice. That's good. All right. What about the next one? Vivian?
to the side of 5.
Which way to the side? To the right or to the left?
Right.
Right 5?
And up 4.
Up 4. All right. Got it. All right. Done with that. And then, what's that? Oh, I'm not there yet. Okay. What about the next one, Elizabeth?
So over 8 to right.
Over 8 and then
Up 2.
up 2. Got it. All right. And then what about the next one, Emma?
To the right 5.
To the right 5. Okay. Good. And now it says connect the points in order. Okay. So I'm going to go from that point to that point, 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 right back to the beginning. And then it says identify the figure, explain your reasoning. Now, Isabella, did you say that? Did you say what it was? What did you say it was? Okay, I like it. It's pentagon. It has 5 sides, right? That's true. I like that because it has 5 sides, so we've explained our reasoning there. Okay. Also, do you see it's a trapezoid on top of another trapezoid? I mean, if I drew a line, but that line's not there. But I mean, I could find the area of those two things if I wanted to. Emma, quickly.
It's an arrow.
It's an arrow or a crayon or a pencil. Okay.
Or a house. Or Dorothy's house that fell sideways on the
Oh, I've got another one here. Ooh, do I have time? Let's see. It says make a scatter plot of the data. 1997 goes up to 8,413. That's about right there. 1998, 8,332. Okay, that's about right there. 1999, 9,160. Here. Okay. 2000 is 8,332. That's about the same. And then 2001, 6,853. Whoa. Okay. All right, like that. It says this is the number of years. Okay, and this is the finishers of the New York City Marathon from 97 to 2001. Describe any relationships that you see. Well, it looks like it went up and then has dropped over that previous, or the last 2 years there. 3 years? 2, right?
2.
From 99 to 2000 and then 2000 to 2001. I'm going to have to stop it. And I think I'm done. Let's see. We are done. All right. Good job, guys. You're ready for your work.
Bye.